need to get out of this section. Well, I'm not sure yet. We'll have to see. I should give it a little more time. I should not be impatient here. We're just experimenting, trying to figure out what's what on this crazy, crazy platform. But hey, if you're coming in because you found my channel in the just chatting section, somehow, why don't we just chat? Just chat. Put things in the chat and we can just chat, okay? I promise you I will chat if you just chat. The hardest part about high school geometry. Yeah, it's probably the proofs, right? For sure. I mean, this is a really new concept in that you're actually like expected to be able to do right off the bat in that class. And I think it is really difficult. Plus, I don't know. It's like the first time maybe in a young person's life that they learn what like a really rigorous argument looks like. And I mean, that word rigorous there, it really depends on the quality of the teacher. I gotta say, I took geometry in high school. It was a trash course. It was because my teacher was really bad, really, really poor. And you need to have a good teacher if you're going to really be appreciate how one comes about developing their own proofs. You know what I mean? Like that's something that even undergraduates have difficulty in, right? Is figuring out like, how do I go from a theorem to a proof of that theorem or a proof of that claim, right? It's really hard. So I would say that class is extremely challenging. It's very different in character from other math classes that you take, in which it's a lot about like drilling and rote memorization of technique. It's different than that. So it's I think maybe the expectation, the disconnect between expectation and like a student expectation and what the course is actually like is probably the hardest part. I mean, you can always default on like, well, probability is like, you know, a subjective belief in various things. But quantifying these things in practice is extremely difficult. So in certain very narrowly tailored, simple situations, like I would call making a decision in a poker game, one of those simple decisions, or making a decision in a video game, one of these kinds of, I mean, that's a little bit too simplistic. That's a little bit too, too simple, because video game decisions can be very, very complicated as well. But if you're making a probabilistic decision particularly in a game like poker, then I think Bayes' theorem is extremely useful to have inside your head. But if you're making a decision about like, should I take this job or that job offer, or what sort of field I want to pursue in my life, like these things get very, very difficult, to actually implement. So I guess I would say ideally I would, but I think maybe in practice it's extremely difficult to, and you very quickly run into in analyzing something from a Bayesian perspective, or the Bayes theorem, you quickly run into these kinds of issues, and they feel insurmountable. I hope that answers your question. But yeah, Bayes' theorem is really cool. If like when you first learn about it, it feels like you're solving like all the difficult conundrums, right? You feel like you've unlocked like the master key, that's going to open up all of the doors for you. You're going to be this hyper rational individual, always doing the thing which is quantitatively like correct, provably correct, but then you realize that in practice there are some serious deficiencies there. But for example, like in thinking about like superhuman AI or something like that, I would imagine that a superhuman AI would be appealing to Bayes' theorem pretty often. I don't know. What do you think? How about you, Kramer42? Do you use Bayes' theorem? There are kind of a lot of these two viewer streams that just look like chair streams. What's Kramer's rule? Oh my gosh, it's been a while. I don't know, I forgot. Is it a way of computing determinants or something? Let me look it up. You hardly ever remember it? In linear algebra, Kramer's rule is an explicit formula for the solution of a system of linear equations with as many equations as unknowns, valid whenever the system has a unique solution. Yeah. I wonder if this thing is used. I see. Yeah, I don't know very much about it. I imagine it's relatively straightforward, but I don't know. Like there's a lot of little gadgets in linear algebra that I don't consider to be like super critical or important to learn. Like the main things, like if you want to keep doing math and you want to keep doing physics, the main things that you need to learn about out of linear algebra are the ideas of like vector spaces and linear transformations. That's like what it's all about. And then like the coordinate systems established by bases of vectors, things like that. This to me is the core subject of linear algebra. And there's a lot of other stuff that comes off as a definitely falls under the category of linear algebra, but is less important, I think, in my opinion, to learn. Now, my opinion is probably very different from, let's say, an applied mathematician's view on this. Like, there's these things like the QR decomposition, and like there's a whole bunch of these kinds of things where you can factor a matrix in various ways and stuff. Like UDL or something, or LDU, I can't remember. There's all these weird ones. I can't even remember them. And I guess that must mean, in my opinion, because I feel like linear algebra is like super important, those other gadgets are just not as important to me. But I say that with, I want, if you're listening to that, you should take that with a huge grain of salt. That's UDL, right? UDL. No, it has the different. I might be thinking of something else completely. I would like to use Bayes and be more rational, but I'm almost always guided by the gut feeling, and I'm actually cool with that. Oh, that's great. Yeah.